Hi, so welcome to today's video lesson. And in today's video lesson, we're going to be looking at power, the concept of power, the concept of power. So, what's power? Now, power is defined as the time taken to do work, or we could say the rate at which work is done. So, the rate has to do with time. So rate has to do with time. So therefore, we're going to say that power is equal to work done. Remember that we said that work done is the same as energy, or energy over time taken to do that work is power. Okay, so now we're going to write this as P equals to W over T. Now remember that work done is force times distance. That's force multiplied by distance over T. So I could basically just write this as F multiplied by D over T, right? You can group this together because it's still going to give us FD over T. And so I could say that F, what's distance over time? That's velocity, of course. So I could say that power is also equals to force multiplied by velocity. So we have probably two formulas, if I'm not mistaken. P equals to Vt and P equals to Wt, or P equals to Fdt, as the case may be, whichever formula that you want to go with. All right, so let's take an example on that. So let's say that you have to calculate the power of a pump now, which lifts 500 kg of water. So it lifts 500 kg of water. Let's see, okay, 500 kg of water. So it's lifting the water up. It's lifting the water up. I hope I'm able to draw. Anyways, I love drawing because in physics, if you don't draw, you might not get the question you are asked to do. So it's lifting the water up. Okay, so good. Then through a vertical height of 4 meters. So it's lifting the water through a vertical height of 4 meters. Okay, good. Then what's the mass of the water? The mass of the water is actually 500 kg. And it does that in how many seconds? It does that in 5 seconds. Now we have to calculate the power. What's the power of this pump? Now remember that power is what? Work done over time. Right? Good. Now, what is the work done? Remember, work done is the same as energy. Because you're seeing mass here. So what's the energy that is going to be used up? Now, because this is dealing with height, position, state, what do you think we're going to use to calculate for the work done or the energy? It's the same. Exactly, potential energy. So we're going to use potential energy over time taken. Are you getting it? Good. So potential energy is mgh. That is the work done, or that's the energy used up. Clear. Good. And then we are going to have power equals, what's our mass? 500 grams multiplied by 10 association due to gravity. Then the height is 4 meters. 4 divided by the time. The time is 5 seconds. So 5 here, 1, 5 here, 100. And so that 100 multiplied by 10 is 1000. 1000 multiplied by 4 is 4000 watts. All right, good. So that's exactly what to do. Or sometimes we can be asked to convert to kilowatt, and you just divide that by 1000, and what you have is 4 kilowatt. All right, good. So power is measured in watts. I think I forgot to say that power is actually measured in watts. The unit for power is watts. Okay, standard unit, SI unit of power is watts. Rather than capital W. All right, good. So don't forget that when you're solving physics problem, you always have to put your units. All right, so this is 4000 watts or 4 kilowatts.